Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 7.3 guided notes on triangles. I'm going to start with just some key vocabulary related to triangles, which are formed by three line segments that intersect only at their endpoints. So every triangle is formed by segments that form three different angles, and the vertex of each angle is a vertex of the triangle. Vertices, by the way, is the plural of vertex. So every triangle has three sides, but it also has three vertices as well. Something that's going to be really important moving forward in this lesson is that the sum of the measures of the angles of a triangle is 180 degrees. That's a really important characteristic that we're going to need here throughout the rest of this lesson. There are ways to classify triangles, and we can actually give every triangle two names because we can classify triangles by both their angles and by their sides. So for angles, we can classify a triangle as acute, right, or obtuse. Whoops, didn't mean to move the notes themselves. So let's talk first about those. So an acute triangle is a triangle with three acute angles. All are between 0 and 90 degrees. A right triangle is a triangle with one right angle. The other two will be acute, and that has a tendency to throw students off because they see two acute angles, one right angle, and they think, well, what do I call this thing? Well, it can only have one right angle, which we'll talk about in a moment. So a triangle with one right angle is going to be a right triangle. And then we have an obtuse triangle. That's a triangle with one obtuse angle. That's an angle between 90 degrees and 180 degrees. The other two angles will be acute. Now we typically do this as a pair share, but obviously this is a video. So the question at the bottom of your page says, why can't a triangle have more than one right angle or one obtuse angle? So if we create a triangle with a right angle, so I'm going to start by putting two of our sides that form a right angle. I know I should probably put that box there, but bear with me. I'm not going to put that in. This is a right angle. If I try to add a third side connecting it to either of these that has a right angle associated with it, or even an obtuse angle associated with it, we can see that there's just no way to connect these two endpoints here and still form a three-sided figure or a triangle in this case. The same way if we would make this into an obtuse angle, again, there's just no way to connect these endpoints. Even if I make this shorter, if I make it longer, there's no way to connect it without creating a fourth side, which means it's no longer a triangle. The other thing is I did say that every triangle has exactly 180 degrees. If you have two right angles, you're already at 180 degrees, which leaves 0 degrees for the third angle, which is just impossible. And if you have an angle that's more than 90 degrees, 90 plus something more than 90, now you're already over 180 degrees, which again makes it not a triangle. So that's why we can't have more than one right angle or more than one obtuse angle in a triangle. And that means the other angles are going to be acute, which again does not make it an acute triangle because an acute triangle has to have three acute angles. Now let's talk about classifying triangles by their sides. This is a little bit more challenging for students, I think, because the names are a little bit more complicated. Scalene is our first one, and that's a triangle whose side lengths are all different. All three angles will also have different measures. So if you notice a triangle that has three different angle measures, the side lengths are all going to be three different lengths. And we use these tick marks to represent side lengths. So we've got a single, a double, and a triple, which means that these three sides have different measures or different lengths, making it a scalene triangle. Now, an isosceles triangle is a triangle with two equal side lengths. The angles opposite those two sides will be equal as well. So these single tick marks right here that I'm highlighting in yellow, those represent our two congruent sides. You see that the angles that are across from those are also going to be congruent. They both have the same measure, in this case 44 degrees, and then our third side has a different measure. So if you ever notice two angles being congruent, you know that this is also an isosceles triangle. And then finally, we have an equilateral triangle, which is kind of exactly what it sounds like. It's a triangle with three equal side lengths, which means that all three angles will be equal as well. So we often call this equiangular. So you'll notice that in this case, since all three angles have to be congruent, they actually all have to be 60 degrees, which also means that every equilateral triangle will also be an acute triangle. All right, let's take a look at some examples on the back of that first page of our notes. So it asks us to classify each triangle by its angles and by its side lengths. So taking a look at number 1, I see a right angle in here, which tells me this is a right triangle. I see 3 different sets of tick marks, which also tells me that all 3 side lengths are different. This is a right scalene triangle. Now, if you say that it's a scalene right triangle, is that okay? Absolutely. All right, taking a look at number 2. First off, we notice that we have an obtuse angle up here at the top that I'm going to go ahead and highlight. That means this is an obtuse triangle. I also notice single tick marks here and 2 congruent angles down below that I'll highlight in blue. It tells me that we have an obtuse triangle, but it also happens to be an isosceles triangle since I have 2 angles and 2 sides being congruent. Number 3, we saw this picture on the first page. This is an acute equilateral triangle. All 3 angles are acute, and that also means that all 3 side lengths, since they're all equal, are also going to be congruent. Not because they're acute, but because they're all the same measure. All right, number 4. So taking a look at this one, I notice 2 tick marks here, which tells me that these 2 sides happen to be congruent to each other. So I know that it's an isosceles triangle. But I sometimes have students who guess that this might be a right angle. You can kind of see here that it's maybe not a right angle. We never really want to guess what the angle or side measures are. We can actually find that third angle measure, which we'll be seeing in a few moments anyway. Add up the 2 angles we know, 44 and 44. That's going to get us 88 degrees, which tells me since it's less than 90 that my other angle has to be more than 90, but I could actually calculate it. I could do 180 minus 88. Gives me that third angle is 92 degrees. So that tells me that this is an obtuse isosceles triangle. So again, we never really want to guess. Even up here in number 3, all 3 side lengths look to be the same length. We don't know that, except we know that all 3 angles are the same measure, which means that all 3 sides have the same length. So we always want to do some math or use our math knowledge to help us determine either what kind of triangle it is or what the angle measures are, or side lengths are, in fact. All right, so let's build on this a little bit. Our next 3 ask us to find the value of x in each triangle and then classify the triangle as acute, right, or obtuse. So what you want to do is add the 2 angles that you know. So in number 5, that's 112 degrees and 17 degrees. That gets us 129 degrees. Since I know that all 3 angles in a triangle have to add to 180, just take 180 minus 129 to get 51 degrees for that last angle. Sometimes students set up equations, so they'll write 112 plus 17 plus x equals 180, and then they solve for x. That works too. Now it does ask us to classify the triangle, not the angle. That's an acute angle, but the triangle itself is going to be an obtuse triangle because we have an obtuse angle. So I specified triangle after this so that you knew that it was an obtuse triangle and not an obtuse angle right here. All right, number 6, let's add 62 and 57 to get 119 degrees. Subtract that from 180 to get our third angle measure, which will be 61. My 3 angle measures are 61, 62, and 57. This is an acute triangle. It would also be a scalene triangle since all 3 angles are different. It kind of looks like it's going to be an equilateral triangle. They're all pretty close, but they're not the same length. So that's why it's important not to just guess. Number 7, we have a 90-degree angle and a 22-degree angle. So let's add 90 and 22 to get 112. Subtract that from 180 to get 68 degrees. So this angle right here is 68 degrees, but it's still going to be a right triangle because we have this right angle right down here. Because again, we needed to classify each triangle as acute, right, or obtuse. All right, so let's move on to some more algebraic questions. You had to figure we'd probably get to some of these. So it says find the value of x in each of the following triangles, then find each missing angle measure. So not only do we have to find x, but we also have to find the missing angles. Now in this triangle, number 8, I know this is 24 degrees, but I still need to find these other 2 angle measures. So let's go ahead and set up an equation. We know that the 3 angles have to add to 180 degrees. So I'm going to write x plus 20. I'll go ahead and highlight these for us. So x plus 20, that's going to be this guy right here, plus 24 has to equal 180 degrees. Now let's simplify before we solve. So 1x plus 1x is 2x, 20 plus 24 is 44. Now it's just a 2-step equation, which I know we've been practicing recently just to refresh our memories on this. The inverse of adding 44 is to subtract 44. That gets us 2x equals 136. 180 minus 44 is 136. Divide both sides by 2, and that's going to tell us that x equals 68. So we end up determining that x equals 68. That's super helpful for us. So we found x, but now we have these two angles, x and x plus 20. So our x degree angle is obviously 68 degrees. Sometimes what students like to do is they like to actually just write it right in the triangle, which is fine. I don't have a lot of space, so I'm not doing that. One of the things that I do on the quiz, and you'll see this also on the test, is I'll actually put like x equals and then a blank, so you know to fill that in. And then I'll put x plus 20 equals and a blank, so you know to fill that in. So for x plus 20, what we're going to do is do 68, replace x with 68 plus 20, tells me that third angle is 88 degrees. So our three angles are 24, 68, and 88 degrees, which makes this an acute triangle. It actually almost looks like a right triangle, but it's not. That's an 88 degree angle. And again, feel free to pause the video or go back at any point if you need to copy down some of this work. There's a lot there. All right, number 9, we know these three angles also add to 180. So we've got x plus x. I'll go ahead and highlight them so you can see where they each come from. Plus 2x has to equal 180 degrees. And again, kind of like in our first lesson in this unit, basically we're going to have things that equal 90, equal 180, or are equal to each other. Here's another example where things add up to equal 180 degrees. We've got a 1x plus a 1x plus a 2x. Feel free to put that 1 there if you want. That's going to get us 4x equals 180. Pretty easy to solve. We divide both sides by 4. That's going to get us that x equals 45. So our three angles are x, x, and 2x. Go ahead and slide this down here. So obviously the two x's are 45 degrees. Don't mind that random line there after the second 45. Go ahead and slide this down. Sorry, I was trying to juggle my coffee at the same time as pulling this down. And then our 2x degree angle is going to be 2 times 45, which is 90 degrees. So this one is in fact 90 degrees. One of the questions I got from students was, if there's not a box, could it be 90 degrees? Well, mathematically it can, but if the box is there, we know for sure it's 90 degrees. If it's not, we might have to figure out that angle measure mathematically, which is what we did here. All right, let's go and flip the page and take a look at our next example on this. So in number 10, we have these three angles that have to total 180 degrees. So let's set this up. We've got x plus 23 plus x plus 70, and these can go in any order. I'm just putting them in the order that I have them. It doesn't have to be that order. Plus x equals 180. Sometimes I have students who prefer to put all the x's side by side right at the beginning, and that's okay too. So I did put my x's side by side for this one. So we've got 1x plus 1x plus 1x, which is going to total 3x. We have our constants, 23 and 70, which will get us 93. This is a two-step equation, so let's use those inverse operations. Let's subtract 93 from both sides. And I'm going through the work really quickly, so if you're trying to copy this down, you're definitely going to need to pause the video. Divide both sides by 3, and we're going to get that x equals 29. Now our three angles are x, x plus 23, and x plus 70. So the x degree angle is 29 degrees. That's this guy, the blue highlighted one from above. We have x plus 70 came next. So replace x with 29. 29 plus 70 is 99 degrees. Then, excuse me, we've got our x plus 23. 29 plus 23 is going to get us 52 degrees. So again, some people like to write it in the picture, 99 degrees, 29 degrees, and what was our last one? 52 degrees up here. This one's definitely not drawn to scale, so don't mind this. My pictures are certainly not perfect, but we'll go with them. All right. So let's go ahead and give you a chance to try one of these on your own. Naturally, it's a good idea to do that. Pause the video, give this question a try, and then we'll take a look at your work and solutions here in just a few moments. When you're ready, start the video. All right, how do we do with this? This one was a little tough, I think. So our equation is 14x plus 1. I'll go ahead and still highlight these. Plus our 6x plus 1. Plus 58. has to equal 180. The three angles total 180. Might you be able to find shortcuts in the long run with some of this stuff? Yes. But right now, we're not going to go with shortcuts. We're going to just write it all out. We'll put our like terms, 14x and 6x, our constants 1, 1, and 58 side by side, and simplify this. 14x plus 6x is 20x. 58 plus the other 2 is 60. Subtract 60 from both sides to get 20x equals 120. Divide both sides by 20 to get x equals 6. And we know one of our angle measures. The other two, we've got 14x plus 1. So I took 14 times 6 plus 1 is 85 degrees, and I used my calculator for that. And then 6x plus 1, I took 6 times 6 plus 1. Don't mind this random space. I had a random plus sign in there that I got rid of. That's going to get us 37 degrees. So we've got 58 degrees. This guy's 37 degrees, and then this one's 85 degrees. And again, don't trust this. I did not draw this to scale. So if you pulled out a protractor and tried to measure them, they would not equal what we mathematically found them to be. That's because I create a lot of these practice problems, so I kind of guesstimate where they are. It's not always accurate. All right, so we've got some ratio questions here. Number 11 is done for you. Feel free to read through this example and see how it's being done. We're going to take a look at numbers 12 and 13 together. If you're ready to try, I know number 13 says now you try. So after we see number 12, if you feel comfortable seeing number 13 on your own or trying it, feel free to do that. So number 12, it says the measures of the angles of a triangle are in the ratio 2 to 4 to 6. So you might have thought ratios were going away, but not quite. What is the measure of each angle? So if I know the angles are in the ratio 2 to 4 to 6, that means that the angles could really be 2 degrees, 4 degrees, and 6 degrees. However, obviously 2, 4, and 6 don't total 180 degrees. So we want to keep the same ratio. For example, keeping the same ratio would be 4, 8, and 12 by doubling each of these numbers. These angle measures, 4, 8, and 12, are still in the ratio 2 to 4 to 6. They're just a little bit bigger. So we're trying to figure out, like, what do we need to multiply 2, 4, and 6 by, all by the same thing? So we keep the same ratio, but the angles have to total 180 degrees. So guess and check definitely works here, but I think setting up an equation makes sense too. If we want to multiply 2, 4, and 6 by the same number so that we keep the ratio the same, we can multiply 2, 4, and 6 by x. Let's figure out what we need to multiply it by and set it equal to 180. So we can write an equation, 2x plus 4x plus 6x equals 180. Let's figure out what do we multiply 2, 4, and 6 by to keep that ratio 2 to 4 to 6, but also so they total 180 degrees. Well, 2 plus 4 is 6, 6 plus 6 is 12. We get 12x equals 180. We divide both sides by 12, and we get that x is 15, meaning we need to multiply 2, 4, and 6 by 15 to get angles that are in the ratio 2 to 4 to 6, but also add up to 180 degrees. So let's find the three angles. So I'm actually just going to uncover all of this at once. So 2x is 2 times 15. 4x is 4 times 15, and 6x is 6 times 15. So we get 30, 60, and 90. This is actually a pretty infamous right triangle. You'll eventually talk about, I think you talk about in geometry for sure, and then probably algebra 2. Maybe algebra 1, but I doubt it. So 30 degrees, 60 degrees, and 90 degrees. All right, let's try another one. The measures of the angles of a triangle are in the ratio 1 to 4 to 7. What is the measure of each angle? Again, we could do guess and check here, but I'm going to set up an equation. 1x plus 4x plus 7x keeps that ratio the same, and it guarantees that the sum of the three angles is 180 degrees. If I add 1, 4, and 7 together, I get 12x again. It won't always be 12x. I know for the last two it was, but if you look at problem number 11 above, it wasn't 12x, it was 20x. So it just happened to be for these two that the sum of the angles was 12. I tried to make the numbers, or the sum of the coefficients, I should say, was 12. I try to make the numbers work out nicely for you as we first start this. So divide both sides by 12, x is again 15. But our three angle measures aren't going to be exactly the same, because here we have 1x, which is 1 times 15, or 15 degrees. We have 4x, which is 4 times 15, or 60 degrees. That one is one of the same. But then 7x is 7 times 15, 105 degrees. And you might want to check and make sure they add up to 180 degrees. They will, and they're in this ratio 1 to 4 to 7. All right, so let's go ahead and take a look at this example. This is one for you to try on your own if you haven't already tried one. So let's go ahead and pause the video, give this one a try. When you're ready, start it, and we'll take a look at how you did. All right, how do we do with this one? Most students find this pretty easy once they see a few examples, but they do have a tendency to forget about it once the quiz and the test come into our sites. So let's take a look at this. We've got 5x plus 12x plus 13x equals 180. That guarantees these angles are in the ratio 5 to 12 to 13, but also that they're going to total 180. 5 plus 12 plus 23, or 23 plus 13 is 30, so we get 30x equals 180. Divide both sides by 30, we get that x is 6. So we did get a different coefficient this time and a different answer, thank goodness. So for our three angle measures, we have 5x, which is 5 times 6, or 30 degrees, 12x, which is 12 times 6, or 72 degrees, and 13x, which is 13 times 6, or 78 degrees. You can total these together, they will equal 180 degrees. So a little bit of a different problem there. And again, most students find these problems, find these problems pretty easy. Especially as they start to see some more practice with it. But we don't want to forget about this because this will come into our sites here when we have our quiz and when we have our unit test as well. All right, number 14 at the bottom of that page is just some more problems with angle measures. It says, given the triangle below, what is the measure of angle A? So since I know that AB and AC are both 7 inches, I know that the angles that are across from them are also congruent. So I know that these two angles have to be the same measure, which means that angle C has to be 28 degrees. This is an isosceles triangle. So let's add 28 and 28 together. It gets us 56. Since we know that our three angles need to total 180, take 180 minus 56 to get 124 degrees for the measure of angle A. All right, so let's kind of shift gears a little bit from angle measures into side lengths. We're going to talk about something called the triangle inequality theorem. There's a lot of things typed in there that you can certainly read through on your own. There are some things you're going to have to copy down though, so let's get into that. The triangle inequality theorem does not deal with angle measures. It deals with the side lengths. In fact, any three side lengths cannot always form a triangle. For example, if I have side lengths of 10, 4, and 3, these, maybe it's inches, meters, feet, whatever, these three side lengths cannot form a triangle. So if this is my 10, let's go with inch side here. This one's 4 inches, and then I try to connect a 3-inch side to that. There's just no way to connect these. Even if I shift the angles a little bit, you can kind of see that we're playing around with that. There's just no way to connect these endpoints or these sides together without creating a fourth side. So not all three side lengths can form a triangle. So luckily we have the triangle inequality theorem, which says that the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. So we have this triangle right here, which is given in your notes. There's three inequalities that have to be true. A plus B has to be greater than C, and the lowercase letters represent the side lengths here. The uppercase represent our endpoints. A plus B has to be greater than C. A plus C has to be greater than B, and B plus C has to be greater than A. So we choose any two side lengths, has to be greater, the sum has to be greater than the third. What you do need to copy into your notes if you're copying this down is this information right here. Just make sure you do that. All right, at the bottom of that page, it's just some examples of working through or talking through the triangle inequality theorem. I'm not going to read through all of this with you. If you feel the need to read through it, absolutely do that. We're going to go right into our examples. So it says to determine whether the given measures can be the lengths of the sides of a triangle. I know that's confusing when it says measures, but we also use measure for side lengths, not just angle measures. So we want to determine, can those three side lengths be the sides of a triangle? We're going to write yes or no. Show your work to justify your answer. So you can see two examples typed in here. Again, I'm not going to read through the examples. We're going to do our examples down below, but you can certainly look back at those if you need some more assistance or you need to look back at some other examples on this. So in number 15, our three side lengths are 5, 4, and 3. So we need to set up three inequalities and confirm that all three are true to determine whether it forms a triangle. So my first inequality was 5 plus 4 is greater than 3. I chose the first two, made it greater than the third. That's 9 is greater than 3. That is a true statement. Then I did 4 plus 3 is greater than 5. These inequalities, by the way, can go in any order. That gets us 7 is greater than 5, also true. Then my last one was 5 plus 3 is greater than 4. I get 8 is greater than 4, also true. This tells me that, yes, these three sides can form a triangle. Let's try number 16. So we've got 5 plus 15 is greater than 10. That gets us 20 is greater than 10, which is true. Then I did 15 plus 10 is greater than 5. That gets me 25 is greater than 5, also true. The last one I did was 5 plus 10 is greater than 15. But that gets me 15 is greater than 15. 15 equals 15, but it's not greater than 15. That's false, which tells me that these three sides cannot form a triangle. Once you determine that one of your inequalities is false, you can stop. So if you happen to choose this inequality first, good news, you're done. Once you determine that you have a false inequality, you know that those three side lengths cannot form a triangle. If you're smart, you can figure out which inequality is going to be false, if indeed one of them will be, and start with that one. Here's a hint. Choose the two smaller sides, 5 and 10, add them together and see if it's greater than the largest side. All right, number 17. Ooh, we've got some decimals here. You might notice by the lack of gray boxes, this is going to be one that is false. So not going to form a triangle. So I chose my two smaller sides, 30.1 and 0.8, which gets me 30.9 is greater than 31. That is a false statement. These three sides cannot form a triangle. Again, work smarter, not harder. Choose your two smaller sides first. If that one is false, you know those three side lengths cannot form a triangle. Now, some of you might say, well then, in number 18, could I just do the two smaller sides, see if the sum of those is greater than the largest side, and stop there? I am going to ask that if you're trying to prove that those three side lengths can form a triangle, show all three inequalities. So in number 18, I took 5.6 plus 10.1 is greater than 5.2. That got me 15.7 is greater than 5.2, a true statement. My second one that I chose was 10.1 plus 5.2 is greater than 5.6. That gets me 15.3 is greater than 5.6, also true. And then the last one, which if any of them are going to be false, it would be this one. The two small sides, 5.6 plus 5.2, are greater than 10.1. Yeah, we get 10.8 is greater than 10.1. True statement, which tells us these three side lengths can form a triangle. Something you're going to want to get used to is showing work even if you think it's unnecessary, because one of the things you'll see in your geometry course, I know it's a couple of years away, is proving statements. And in order to be able to prove statements, you have to show more work than you think is necessary, just like you would in some real life circumstances as well. All right, now the next type of question gets a little bit more complicated. So for the next type of problems, we're giving you two sides. You basically need to figure out what the range is for the third side of the triangle, given two of your sides. So let's take a look at these. And you're going to notice some shortcuts here as well, so we'll talk about those. In number 19, I have sides of 6 and 10. I'm going to let x be my third side, and I'm going to set up my three inequalities, just using x here instead of an actual numerical value. So my first inequality was 6 plus 10 is greater than x. That gets me 16 is greater than x. I did rewrite it with a variable on the left just because I think it makes more sense. So I flip-flopped the x in the 16 and the inequality symbol. I know that my third side x has to be less than 16. So that gives me a little bit of a range. We obviously know x has to be greater than 0, but we also know now that it's less than 16. My second inequality is 6 plus x is greater than 10. We have to solve this one. So we've got to subtract 6 from both sides. That's going to get us x is greater than 4. So I know two things. X has to be less than 16, and it has to be greater than 4. My third inequality is kind of a weird one. We've got 10 plus x is greater than 6. I would be subtracting 10 from both sides here because I have x plus 10. The inverse is to subtract 10. But this gets me x is greater than negative 4. You're always going to get an inequality that just doesn't make a lot of sense because obviously the third side has to be greater than negative 4. It has to be greater than a negative number, of course. It's got to be positive. So what I know here is that x has to be greater than 4 and x is less than 16. So this is sufficient for a solution, but I also wrote it, this is what we call a compound inequality, where we put our third side in the middle, our lower range or our lower boundary, I guess we could call it, on the left, our upper boundary on the right, and then we use these less than symbols. This tells me that my third side has to be greater than 4 and less than 16. So that third side could be 4.2, it could be 8, it could be 10.9, it could be 15.3 repeating, but that third side has to be greater than 4 and less than 16. All right, let's try another one of these, number 20. 25 and 32 are the two sides we know. X is my third side. So first inequality is 25 plus 32 is greater than x. No need to solve here. That just gets us 57 is greater than x, or x is less than 57. My second inequality was 25 plus x is greater than 32. I subtracted 25 from both sides to get x is greater than 7. My third inequality is 32 plus x is greater than 25. I subtract 32 from both sides to get x is greater than negative 7. But again, this is kind of a throwaway one because we already know that x has to be, that third side has to be greater than 7 and less than 57. So then I just write my two inequalities together. X is greater than 7 and x is less than 57. Or you can write it as a compound inequality like this. Lower boundary on the left, upper boundary on the right, less than symbols between, because we need x to be greater than 7 and less than 57. If you flip these symbols around to be the greater than symbol, it's not going to make sense. So be careful if you choose to do that. All right, last two of these, numbers 21 and 22. 36 and 19 are our two side lengths. We want to find the third side length. So my first inequality is 36 plus 19 is greater than x. That gets me 55 is greater than x, or x is less than 55. So that third side has to be less than 55. Second inequality, I happen to choose the one that doesn't really fit for us. I've got 36 plus x is greater than 19. Subtract 36 from both sides, we get x is greater than negative 17. Again, this one's not reasonable. We can get rid of it. My last inequality, though, I do need, and something you might notice is that the one that doesn't work and one of the ones that does, your lower boundary, they're going to be opposites. So whatever your lower boundary is, in this case 17, the other one's going to be negative 17. The same way with these two, our lower boundary was 4, we got one that involved negative 4. Lower boundary was 7, we got one that involved negative 7. So my last inequality, 19 plus x is greater than 36, subtract 19, we get x is greater than 17. So my lower boundary is 17, my upper boundary is 55. So we know that x has to be greater than 17 and x is less than 55. So compound inequality, if you choose to write it, looks like this. All right, last one. We've got 5.7, 5.7 and 8.4. Third side is going to be x. So my first inequality, 5.7 plus 8.4 is greater than x. That gets me 14.1 is greater than x, or x is less than 14.1. So that's my upper boundary. My second inequality was 5.7 plus x is greater than 8.4. I subtracted 5.7 from both sides to get x is greater than 2.7, which is my lower boundary. And then my third inequality is going to be the one that doesn't really fit for us. I have 8.4 plus x is greater than 5.7. Subtract 8.4 from both sides to get x is greater than negative 2.7. And again, notice your lower boundary and the one that doesn't work are going to be opposites. So we can write that x is greater than 2.7 and x is less than 14.1, or our compound inequality that looks like this. All right, number 23. It says, which of the following could be the length of the third side of the triangle? So I've got 6 and 8. I'm going to let my third side be x. So let's set up some inequalities. 6 plus 8 is greater than x. That gets us 14 is greater than x, or x has to be less than 14. So guess what? I can eliminate choice B. I can eliminate choice D. Let's look at another inequality. 6 plus x has to be greater than 8. Subtract 6 from both sides, we get x is greater than 2. Choice A is not greater than 2. We can eliminate that. It leaves us with one choice, letter C, which is 13. That's the only side length that's greater than 2 and less than 14. By the way, some of you might be recognizing at this point a little bit of a shortcut here. Your upper boundary is always going to be the sum of the numbers. So you notice probably here that if you added 8 and 6 together, your upper boundary was 14. So that third side has to be less than 14. Your lower boundary is the difference of the numbers. So if I subtracted 8 and 6, I end up getting 2. My lower boundary is 2. That happened on all of these other examples. Let me take an easy one like number 19. The upper boundary was 16. 6 plus 10 is 16. Our lower boundary was 4. 10 minus 6 gives us 4. That's going to be helpful, especially if you're dealing with a question that doesn't say you have to show your work. What you could do is you have a multiple choice question like this. Find your upper and lower boundaries using this shortcut, and then that helps you eliminate some of your choices a lot quicker than setting up inequalities. All right, so at the bottom of that page, it says to state in words what you know must be true about 1, the side lengths, and 2, the angle measures of any triangle. Let's start with the side lengths. We know from the triangle inequality theorem that the sum of any two side lengths, not sides lengths, let me fix that, of any two side lengths of a triangle must be greater than the third. So the sum of any two side lengths of a triangle must be greater than the third. And what about the angle measures? Well, the sum of the angle measures of a triangle must equal 180 degrees. These are two very different things. Are there relationships between side lengths and angle measures? Yes. But the inequality type of thing is for our side lengths. Adding up and setting equal to 180, that's for angle measures. So let's take a look at these two problems, because this is where students get mixed up. So it says, what is the difference between the two problems below? Problem A, can 3, 5, and 8 be possible side lengths of a triangle? How do you know? Problem B still involves 3, 5, and 8, but it says the angles of a triangle are in the ratio 3 to 5 to 8. What is the measure of each angle? Well, for problem A, this is where you want to set up the inequalities and see if they are true, because we're talking about side lengths. That's triangle inequality theorem. So anytime we're talking about side lengths, and that's what it says here in the problem, your head wants to immediately go to triangle inequality theorem. That means I need to set up the inequalities. Whereas in problem B, we're talking about the angles of a triangle. So your mind needs to immediately go to, hey, I'm going to add these up and set it equal to 180. So this is where you want to set up an equation and set it equal to 180, like this. 3x plus 5x plus 8x equals 180. I give problem B a lot of times or something similar to this on a quiz or a test, and students will immediately start writing these inequalities. But that doesn't fit here because we're talking about the angles of a triangle. So you really want to make sure you read carefully to determine what we're trying to find here, because otherwise you're going to end up doing it wrong and setting it up incorrectly. All right, I know there's a lot in this lesson. Again, another 40-minute video for this entire lesson, but there's lots of little important things here. Some things you've seen before, but also some algebraic things that maybe you haven't seen before. Obviously, there are things we'll continue to work with in class as well. Thanks for listening.